Hello and welcome. In this video, we will go over bubble sort in ARM assembly language. We will implement the algorithm in the CPULator simulator, the platform that we've used to cover many principles in ARM programming. And without a further ado, let me go ahead and do it here and see if I can get the points across. So as you know, in bubble sort, the way the algorithm works, the algorithm goes over a list of elements and swaps the adjacent elements if the first is smaller or larger than the second one, all the way to the end of the list, and then it will repeat until there is no longer elements that need to be swapped. If you are interested, you can probably look up some articles online or read a Wikipedia page or refer to your textbook to see how the algorithm actually works. But I'm assuming you know the basic principle in bubble sort in order for us to write the code. But anyway, so the idea here is that we need to compare two elements and then swap them if the first one is bigger than the second one, and keep comparing that first element to the end of the array and repeat the comparison from the beginning until there is no longer a swap that's needed. All right, let's get started. Before I write the algorithm itself, let's do some simple setup here that you are probably familiar with. I'm going to write an element array. I'm going to define some array and some few elements in it, and then we'll code that. So my elements will be in my data section. And if I want to, if I like to, I can use the align to make sure that they start at a boundary of a multiple of 4. Or I can just go ahead and to my array here is called array. And I'm going to use a word, meaning it's an array of integers. And let's say I'm going to generate some random values. Obviously, I'm going to do them out of order, randomly. See, maybe 3, 2, and 7, for example. And then I'm going to use the .eq u. And I need to get the size of the element of the array so I can figure out later how much is or how many elements are in my array. So I'm doing this setup to kind of give you guys an example, but I also want to make it work for any size of array. So I'm not going to hard code how many times I have to step through the loop and how many elements I have to compare. And to do that, I'm assuming that I don't know how many elements, and I'm just going to grab the size of the array, which is given by this, and my array name is ARY, and I'm going to equate this to the size. So I'm basically here declaring a, let's say, a variable or a symbol, rather. This symbol is called size. You can call it whatever you want. And this is saying, give me how many spaces my current location is from this label. And this label refers to the array. And basically I'm saying from my location, which is referred to by this dot, from my location to the previous label, there's going to be so many bytes or so many addresses. And knowing that will allow me to figure out how many elements are in the array. So in this particular example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Each element is 4 bytes because I have a word directive here. So 9 times 4 is 36. So this size, this label, this symbol will have the value of 36. It will be from the beginning of the array that's indicated by this label to this dot, which is technically this very line right here. That will be a difference of 36. I'm going to use this information later while I'm navigating my swaps and loops for my bubble sort. So anyway, so assuming that I have an array that's sitting in my data section, I'm going to do my, I need my text section for the instructions, and I'm gonna do the standard start to indicate the beginning of my program. Now, how does the algorithm work? Before I actually type the instructions, let's go ahead and kind of like type how this works in English first. All right, so basically the way the algorithm works is it will, let's say, compare, well, start with element number 1, compare to 2, swap if 1 is larger than 2, repeat comparison until reaching the end of the array. Here, if we swap, actually also we need to make a flag that a swap took place. You'll see why in a minute. So, and then you repeat until you reach the end of the array. And then here you're going to start again from the beginning of the array. Beginning of the array. So basically start again, meaning loop again from the beginning of the array, and then compare the first element to the second element and go through it. And in this case, you will actually start from the next element instead of the first element, and then indicate if there's a swap that took place and so on. And then obviously here we're going to check if no swaps took place, we are done. So a few things that you can see from this language. One is I need to start with the first element. I need to make a comparison. I have the first loop that grabs the first element and run with it. I have another loop that says, have I compared all of them? And I have a flag that indicates whether or not I have reached, I have made a swap. And I need to know when do I stop, like, reaching the end of the array. I need to know when do I get to the end of the array, so I don't compare things down the road that are not part of my elements or not part of my array. As you know, in assembly, you can keep going. You have, you're in control of what you're doing with your low-level kind of the hex values in memory, right? Like if, for example, if I have something else that's happening here, like I have a .byte or another array of stuff, if I don't stop at the right moment, there's a potential hazard that I can keep going. So I need to know when is the end of the array. All right, so now let's say I have my first loop. First thing first, I need to point to the beginning of the array. So I'm going to make a pointer that points to my array. And then I'm going to move, let's pick some register for a flag, because I need to keep track of whether or not the swap has happened. So let's say this will be R7, and I'm going to load the value 0 into it. I can also put some stuff before the loop starts, actually. I can also start with moving the size of the array into, let's say, any register, R8, for example. And this symbol you said is size. So this is stored in size. This is the size of array in R8. We need to point to it. We can point to it here, and because of the loop, I have to point to it again later. So I'm going to do R0 equal ARY. Okay. Address of array in R0. And then I'm going to do add R8, R0. This will be the absolute address ending in R8. I'm going to use this later to know when I get to the end of the array. Basically, I'm saying here if I'm pointing to the beginning of the array and I know the size of the array is in R8, if I add these two together, that will give me the absolute address of that array. Because again, I'm trying to write this code that kind of works in a generic way. I don't know if there's something before it. I don't know if there's something after it. So give me the beginning, add the size of the array. That will give me the final address of the last element in the array. So now I'm going to go, like I said, to continue with the loop. And down here, maybe I can zoom in just a tiny bit here to make it better. So I have a pointer that's pointing to the array. I have a flag. I'm going to use this as a flag to indicate whether or not a swap has taken place. Okay. And then I need to do another loop. Let's call this loop 2. And now I'm going to start loading elements, comparing them. If a swap has to happen, I'm going to branch, perform the swap, come back, continue the loop, repeat, check the flag, and if that's the case, if there's no swaps happen, or continue if there was a swap. So I'm going to load the first element into my R1, and R0 is the pointer to it. So this is first to compare in R1. The first element to compare is in R1. I'm going to grab the next element, which will be the pointer plus 4. Why 4? Because I identified my elements as integers, and an integer is 4 bytes, so I need to skip 4 spaces, and this will be my second element that I'm comparing. Okay. And then I'm going to simply just compare the two, compare R1 to R2, just doing a compare. And then I'm going to, let's say R1 is the first element, R2 is the second element. If R1 is bigger than R2, I need to swap them. So I'm going to branch and link, because I need to know to come back. So BL, branch and link, but under what condition? Under the condition if greater than. Basically, if R1 is bigger than R2, I have to branch to some location, to some subroutine, to swap them and come back. Now, because I need to come back, I put this L here. You can also, theoretically, you can do branch if greater than. That's an instruction. BL is another instruction that says branch, but also keep the return address in my link register, so I can come back to this line. That would have been here, this line. Actually, I mean, the one that's indicated with the dots. Okay, so branch if greater than to, let's say, some label called swap. So now let's say I go down here. Before I continue with my main loop, I'm going to do the swap here. And under swap, I need to basically swap the two elements together. So I'm going to store. How do I swap them? I'm going to store the element from R1 in the location that's of the second element, which was this one, right? If you notice, the second element was here in this location. So what I'm doing with this instruction is I'm putting the first element, which is R1. We said R1 is the first element. I'm putting it in this address. So I'm storing the first element in the location of the second element. Okay. And I'm storing, similarly, I'm storing the second element in the location of the first element. Right? The two elements are saved in R1 and R2. The address, I'm manipulating the address basically at where I'm storing. I'm storing the first one in the address of the second, and I'm storing the second one in the address of the first. Once I'm done with the swap, I need to move back the program, or move back the, or what's the word I'm looking for? Get back the program counter value from my link register. Why? Because I use the BL instruction here, branch and link. So now the link register contains the return address. So I'm moving it back into the program counter, so that once this is done, once this section of 4 lines are done, I'm gonna come back to this location right here. So what happens next? Well, because I did a swap, I'm going to also move 1 into my flag. And I'm also going to put that greater than condition. I need to indicate that I did a swap, and we say we have a flag that's been held by R7. So I'm going to put 1 into R7. Similarly, you could have moved this instruction into here and then just say like move R7 hashtag 1. That's the same. It's no problem. And then I need to advance my pointer. So now I'm going to add R0 hashtag 4. Oops, hashtag 4 to advance a pointer to the next element. And I need to compare if my pointer is pointing to the last absolute address that we were talking about. Like, have I reached the end of the array or not? Because that will indicate whether or not I need to stop comparing. I can't keep going if I reach the end of the array. So if it's less than, so branch, if it's less than, I'm going to go back to loop 2. Essentially, if I did not reach the end of the array, I can perform a comparison again. So I'm going to come back here. I'm going to grab the element that resides at that address that's held by R0 and grab the second element next to it and then do the comparison. If it's bigger than, if the first one is bigger than the second one, move branch to swap them, flag that I did a swap, come back, etc., etc. So I'm going to repeat this over and over again until I reach the end of the element array. Now, if it's not the case, I don't go back to loop, but I need to also compare. I need to know if my flag has been set, my swap has been set. Because if I reach the end of the array and this flag is 0, that means I haven't done any more swaps. I'm done. The array has been sorted. But if it's not, then I have to keep repeating, right? So I'm comparing the flag to 0. And if it's equal, like I said, I'm going to branch back to end. And somewhere here, I'm going to write a label here that's called end. And you can end it with the .end directive if you like. Essentially, we're saying if I reach the end of the array, I haven't done any more swaps. Maybe there was no swaps to do. Maybe there was only one to do. Who knows? I branch to the end, I'm done. But if it's not the case, I'm going to do another comparison between R0 and R8 and then see if they are equal. And if that's the case, I need to branch back to loop. Otherwise, I need to branch, if not equal, to end. Now, I need to branch, when I branch back to loop, what I'm saying here, when I branch back to loop, I'm going to reset the pointer to point to the beginning of the array. I'm going to reset the flag, and then I'm going to start with these instructions, get the first element, get the one that's next to it, make a comparison. If the first is bigger than the second one, make a swap, and so on. And this is pretty much it. It's actually, I believe, for me maybe, this is simpler than coding this in other languages. Like how many instructions we have here? Barely 20 lines, right? Or maybe around 20 lines from line 23 down to line 46. So 23 lines, 24 actually, to do this bubble sort in assembly. I don't know, but for me, I found it easier maybe than writing this code with other languages. But anyway, let's take a look. Let's see if this works. I'm going to compile and load, and then we're going to step through it and inspect the memory content before and after we run the algorithm. So let's take a look at the memory. So my assembly, let me go back to my assembly lines here. So I have 5, 1, 11, 9, 10. Let's see if I can look at them. 5, 1, 11 is B, 9, 10 is A. Here's A right here, and so on. So it looks like my array starts at this location, or it starts at this location, and it ends here. So let's go step by step for the first iteration and then see what happens. So if I'm stepping over, Let's see, where is that here? Okay, so I'm loading the address. I moved 36 into R8. Okay, it makes sense. 36 is actually the size of my array. We said there is 9 elements in it, and each element takes 4 bytes. 4 times 9 is 36. So I do see 36 into R8. 36 decimal is 24 hex. I do see 24 in R8. Then I'm going to load the address of that beginning of the array into R0. And then it looks like R0 contains the value of 58. And if I go to my memory, this is address 50, this is address 54, this is address 58. So it is pointing to the first element in my array. Now I'm adding this to get the absolute value, and then it looks like the last thing, the element will be at the end of the array will be at address 7C in hex. And now I'm going to go and load the first element, put it into R0. Sorry, I'm pointing to the first location in my array, and then I'm going to reset the flag to 0. So nothing has changed with R0 because I already been pointing to it. Now I'm loading the first element into R1. R1 contains 5. I load the second element into R2. R2 contains 1. I'm going to compare them, and obviously 5 is bigger than 1. So I'm going to see something happen in the CPSR. The flags will be set. Okay, so the flag has been set here. So I'm going to jump if greater than, which is the case, jump and link. Now I'm going to pay attention to the return address. So I'm going to pay attention to this program counter, and I'm going to pay attention to this value right here. So if I step over, I branch and link, branch if greater than, and it actually did do the swap. Maybe I should have clicked on step into instead of step over. When I clicked on this, it actually went and it executed the instruction at the swap, and then it came back to the next instruction. If I look at the memory, I do see that the 1 and the 5 has been actually swapped. So maybe I can come back to it on the next iteration and show you what happens if you step into it instead of stepping over. Anyway, I did do a swap, so now the flag that's held in R7 should be 1. So if I step over this, I do see 1 moved into R7. And I'm going to add 4 to my pointer to point the next one, compare to see if it's reached the end of the array, which is not. If it's less than, I'm going to branch back to loop 2. So here we go, because I did not reach the end of the array. It's obvious. So maybe now I'll remember to actually move into when I get to this point. So again, I'm pointing to the first element, or in this case, the first element is actually the second element because I just added 4 to R0. So now R0 is actually pointing to the second element in the array. So I'm going to step over it and then grab the next one. So now, if you notice that 5 now is the first element because it's pointing, the address originally, or the pointer was pointing to 1, or it was pointing to this location that had 5, and it was and this location had 1. Then after we did the swap, this became 5, and this was, or turned into 1. Now my pointer is already now pointing to this location, and this location does have 5 because it's going to compare now the 5 with the B. And then it's going to compare the 5 and the 9 and so on. But actually the 5 is less than a B, so it's not going to do the swap. Okay, so I'm going to go back to my disassembly here. I'm going to compare R1 into compared to R2. Now R1 contains 5, R2 contains B. There is not going to be a swap because 5 is less than B. So if I actually, even if I step into, nothing is going to happen because 5 is less than B. The flag is not going to change because we've already, it already has 1. There's no changes there. No swap that took place was there. Anyway, so I'm going to step over these instructions. I add 4 to R0, compare it against R8. If it's less than, I'm going to branch back to loop 2. So I'm going to add 4 into my pointer. So now I'm going to compare. Now the first element becomes B because it is the next element that was in my array. And the next one, the next element to be will be 10, right? So I'm comparing B to 10. And now I am going to see a swap happening in a minute. So I'm going to click on step into. It went into the swap. It's going to store. So if you look at memory here, where's my, there's my B and there is my 10. I'm going to see these two values flipped, okay? So if I step over, I see the B is written here. And if I step over one more time, I see the 9 is here. So I did, in fact, flip the 10 and the B, or the 11 and the 10. And now the program counter, like I said, I was trying to show you this a little bit ago. The program counter is going to be retrieved from the link register. The link register is right here. It contains the value 24. And notice this program counter right here is at address 50, which makes sense. It's right here. This is 50, this is 50, but I need to override that 50 with the value of 24 because I have to go back to my next instruction after the compare before I made that jump, which happens to be this line, right? So which means, I don't know if I clicked on something when I double clicked it, but it's supposed to be here. So if I step over, the program counter now is 24, which means the next instruction executing will be this move greater than R7 hashtag 1. We already have 1 here, and so on. So what I'm going to do is I'm going to put a maybe a breakpoint every time I'm doing a swap, and then I'm going to click on continue. So if I click on continue here, you can keep an eye on these values in memory. Okay. And I'm going to click on it multiple times, and you see that the B is propagating through the memory. Well, B is less than C, so nothing's going to happen on the next one. And then the C and the 3 have been swapped. The C and the 2 will swap. The C and the C and the 7 will swap on the next one, right? Anyway, so, and now the first pass is done with the bubble sort. And as you can see, there are still elements that are larger that are behind, right? So like B, for example, is bigger than 3 and it needs to be swapped. So now the algorithm finished with the first pass and it's going to do the second pass to do the same thing all over again. It will continue repeating this until there's no more swaps happening between two elements from the beginning to the end of the array. And when that happens, the algorithm is done. So I'm going to continue. And if I actually go back to the disassemble, remove this, and just click continue, and then stop. If I go back to my list, I do see the values. So I have 0, 1, or I have 1, 2, 3, 5, 7, 9, A, B, C, which is the listed or the sorted list of my array elements. Okay, actually, let me double check this. I'm not sure if this 0 was here or it got sorted without it being intended to be sorted. Let me refresh this page, copy and paste my code, and see if there was something not right quite here. Let's see, might be off by 4 locations. So let's see, our address, our array starts with 5, ends at 7. There's that 0. And I think that 0 is being sorted. Let's see, continue, memory. Yeah, that 0 is being... So, all right, so it looks like the pointer is going one more location further than it's supposed to. Let's see if we can fix that. We have an idea. So before we... Let me see here. That's a good exercise, actually. All right, so let's stop at 4 spaces before. And let's see, we go to memory. Okay, so we do have that 0 here. We have this 0 here. If we don't get 2 zeros back to back, then this should work. It should be correct. Compile load, right? That's what we did. All right, continue, stop. All right, 1, 0. All right, it looks like we did not grab this 0 like last time. Let's double check. Let me add a word here. Let's say 12 and compile it. Let me look at memory. So this is my 12. That's before the array starts. This is the first element of the array. This is the last element of the array. If I click continue, great. Here we go. All right, so it was just reading 4 bytes further than it's supposed to. But anyway, here you have it. Doing bubble sort in ARM assembly. I hope you enjoyed this video and you learned a thing or two. Good luck and have a good one. Thank you for watching.